When you look up at the night sky, you see stars scattered across the darkness, each one glowing like a small jewel. But what we cannot see with our eyes is far greater, far stranger. Behind those pinpoints of light lies an invisible structure stretching across the universe, a silent design that connects galaxies together like beads threaded on a string. Astronomers call it the cosmic web. It is not built of bricks or wires, but of gravity itself, pulling, shaping, weaving. Tonight we are going to drift into this hidden skeleton of the universe, the grand tapestry that holds everything in place. The night sky is not empty. Threads you cannot see. When you step outside on a quiet evening, the night can feel endless. The stars seem far apart, scattered without reason. But what if that space between them is not truly empty? What if it is laced with threads invisible to your eyes? Scientists discovered that the universe has a hidden architecture. Galaxies are not random, but connected by gravity, forming something far larger than we ever dreamed. It is like looking at frost on a window pane, delicate yet vast, each tiny branch a frozen whisper of cosmic order. The truth is, the universe is not chaos. It may appear random, but deep beneath is a pattern. Imagine a spider's web stretched across billions of light years. The strands are filaments of galaxies, each one glowing faintly, each one bound by unseen forces. Between them lie giant voids, darker than any night we've ever known. These are not just gaps, but oceans of silence, separating islands of light. The night sky, then, is not a blank canvas, but a hidden weave of brightness and shadow, stitched across eternity. What makes this more curious is that you cannot see these threads directly. Even the best telescopes show only the bright dots of galaxies, never the net that binds them. Yet through patient mapping, through millions of observations, astronomers began to reveal what lies behind the curtain. And what they saw was hauntingly beautiful. An endless design repeating itself like veins inside a leaf, magnified 1,000 times. The more we look, the more we realize emptiness is never truly empty. Sometimes you might think about your own life, how moments feel disconnected, scattered. But when you step back, you notice the pattern. Just as our lives are bound by unseen connections, galaxies too follow invisible lines. Gravity does not ask permission. It pulls everything into place. It arranges stars, planets, and clusters into order. And if you look carefully enough, you might sense the faint echo. Your life, too, belongs to a greater thread, one you cannot always see, but one that holds you still. So when you gaze at the sky tonight, remember, you are not looking into emptiness. You are staring into a living web, where galaxies are beads on strings of gravity, stretching into infinity. And this is only the beginning of what the cosmic web reveals. As we open more of its secrets in this video, the night sky will never look quite the same again. A silent net holding the universe. Together, it is difficult to imagine something that holds galaxies the way a net holds fish. Yet that is exactly how astronomers describe the cosmic web. A net, vast beyond belief, woven by gravity over billions of years. It does not shimmer or sparkle, it does not make a sound, and yet it is always there, wrapping around clusters of galaxies, pulling them into quiet harmony. If the stars are voices, then the web is the silence between notes that makes the music whole. To understand this net, think of rivers on Earth. They carve valleys, bring life, and shape the land. In space, rivers of hydrogen flow along the web's filaments, feeding galaxies, giving them the fuel to create stars. Where rivers meet, cities form. Where filaments meet, galaxies bloom. The cosmic web is not only a structure, It is a lifeline. Without it, galaxies would drift alone, starved of matter, fading into nothingness. Instead, the net feeds them endlessly, ensuring the universe keeps glowing. But what makes it silent is even more fascinating. The net is built not just of matter we can see, but mostly of dark matter, invisible, untouchable, unknown. Dark matter does not shine, it does not reflect light, and yet it outweighs the visible universe many times over. It is the invisible skeleton of everything we know. Without it, the net would collapse. Without it, galaxies like our own Milky Way would simply fly apart. Gravity, guided by this hidden substance, is what ties the threads together. You may wonder, if it is so silent, how do we even know it exists? The answer lies in patience. By watching how galaxies move, by mapping their positions, astronomers saw the pattern emerge. A structure too precise to be chance. It was like noticing the ripples on water, even when the wind itself was unseen. Through this, the silent net revealed itself, a ghostly presence that gives shape to all of creation. The more it was studied, the more real it became. And in this silence lies a lesson for us. Sometimes the strongest forces in life are the ones we do not see or hear. Love, memory, gravity, they all pull us in ways beyond our senses. The cosmic web is proof that silence does not mean absence. Instead, silence is often the hand that holds everything steady. Ahead in this video, we'll drift deeper into how scientists first discovered these threads and how the universe revealed its hidden net to us, what astronomers call the cosmic web. The phrase itself feels poetic, the cosmic web. Yet it is not poetry, but science. Astronomers coined this term after decades of discovery. At first, the universe was thought to be uniform, the same in every direction. But as surveys grew larger, something strange appeared. Galaxies were not scattered like raindrops. They gathered into lines, sheets, and clusters, forming a pattern too clear to ignore. It was as if the universe itself was weaving a web in silence. When computers became powerful enough, scientists created simulations of the universe after the Big Bang. They let gravity and dark matter interact across billions of years. What they saw was breathtaking. Out of randomness emerged a pattern, filaments stretching like highways of galaxies, clusters glowing at intersections, and vast voids between. When the simulated universe was compared with real data, they matched almost perfectly. The name cosmic web was born describing not just what it looked like, but what it truly was. The hidden architecture of reality. To picture it, imagine holding a sponge or a piece of coral, full of holes with delicate strands connecting the solid parts. That is how the universe looks on its grandest scales. But instead of water flowing through, it is galaxies, stars, and gas. The cosmic web is not just beautiful, it is efficient. It is how the universe channels its matter, deciding where galaxies will grow and where silence will remain. The name is simple, yet it captures the heart of one of the most profound discoveries in astronomy. Some might ask, why a web and not a network or a net? The word web carries with it a sense of fragility, of something spun carefully and stretched across space. It reminds us of a spider's web glistening in morning light, delicate yet strong enough to hold against the wind. That is the essence of the cosmic web, fragile in appearance but unbreakable in design. It is both a scientific fact and a metaphor for the connections that bind all things. In the end, the term cosmic web is more than just language. It is a window into how humans interpret the universe. Science revealed the pattern, but poetry gave it a name. And together they allowed us to see the cosmos not as chaos, but as harmony. In the next part of this video, we'll wander into the earliest days of discovery when scientists first began noticing these strange patterns among the galaxies. Why galaxies are never truly alone. If you could drift beyond the Milky Way, you might expect to find yourself surrounded by emptiness. But galaxies are rarely alone. They live in groups, clusters, and superclusters tied together by gravity. They are part of families connected by the threads of the cosmic web. The idea of a lonely galaxy floating in silence is more imagination than reality. Instead, the universe is a vast neighborhood where every galaxy has its place, whether in crowded cities of light or on the quiet edges of filaments. Our own galaxy, the Milky Way, is part of what astronomers call the local group. About 50 galaxies bound together, and even this small group belongs to a much larger cluster, the Laniakea supercluster, containing hundreds of thousands of galaxies. All of these sit along the strands of the cosmic web like beads aligned on invisible threads. To travel across them would take billions of years, but their connections remain strong, unbroken by the ages. Gravity does not let them drift too far from one another. This closeness is not only about distance, but about interaction. Galaxies pull on each other, trade gas, and sometimes even collide. These encounters shape their stars, their size, their very destiny. The cosmic web ensures they remain connected, passing along matter like lifeblood in an infinite organism. Without these connections, galaxies would wither. Instead, they flourish, fed by streams of gas from their filaments and strengthened by the company of neighbors. Even the empty voids remind us of connection. They are not mistakes, but part of the balance. Galaxies cluster along the edges of these voids, defining their boundaries, shaping the cosmic pattern. Just as silence defines music, emptiness defines connection. No galaxy lives outside this pattern. Even those that appear distant still belong to the larger weave, caught in its threads of gravity. In truth, no galaxy drifts alone in the universe's design. And so when you look at the Milky Way stretching across the night, remember that it is not a solitary wanderer. It is part of a grander family, woven into a net that stretches across the cosmos. Galaxies are bound to each other just as we are bound to the universe itself. And as this story unfolds ahead in this video, we will see how this vast structure first began to emerge after the Big Bang. A journey into the hidden skeleton of the cosmos. What lies behind the stars we see is not random. The universe has a skeleton, a framework of dark matter and gravity that holds everything in place. Scientists call this skeleton the cosmic web. It is invisible to our eyes, but not to our minds. Through data, simulations, and deep observation, we can trace its outline, like seeing the bones beneath the skin of creation. It is a map that explains not only where galaxies are, but why they are there at all. The cosmic skeleton was formed in the earliest moments after the Big Bang. Tiny ripples of density, no larger than a whisper, grew over billions of years into vast filaments of galaxies. Gravity pulled matter into strands, and from these strands came stars, planets, and life itself. Without the skeleton, the universe would be shapeless, formless. It is this framework that gave the cosmos its order, its beauty, its meaning. To glimpse it is to glimpse the blueprint of existence. But it is not a rigid skeleton. It shifts, stretches, and evolves. Galaxies flow along its filaments like rivers along valleys. Clusters gather at its intersections like knots on a rope. Even now the skeleton is alive, moving slowly, reshaping itself under the push of dark energy. It is a reminder that the universe is not fixed, but forever changing, even on scales too vast for us to notice. the skeleton breathes in its own cosmic rhythm. When we map the cosmic skeleton, we are not just making charts, we are revealing the hidden order behind the chaos. It is like seeing the scaffolding of a cathedral, a design too vast to build without structure. And the more we map it, the clearer it becomes. We are part of this framework. Our galaxy, our stars, even our lives, all trace back to this invisible design. We are walking on the bones of the universe. So when you think of the cosmic web, think of it as more than science. Think of it as a journey into the skeleton of the cosmos, into the hidden threads that make everything possible. And ahead in this video, we'll begin to uncover how scientists first found proof of this skeleton and why it changes the way we see the night sky forever. How scientists noticed patterns beyond randomness. At first, astronomers thought galaxies were sprinkled across the sky like dust scattered by the wind, random without design, but the more carefully they mapped them, the stranger it seemed. Galaxies were not just scattered, they formed shapes, chains, arcs, even walls, stretching across space. The human eye is drawn to patterns, and the universe began to whisper one through the darkness. In the 1970s and 80s, large surveys of galaxies revealed something no one expected, clusters connected in long strings. It was as though someone had traced faint lines across the cosmos, joining galaxies like stars in a constellation. But these were not imagined drawings. They were real, vast, stretching millions of light years. The randomness was fading. Order was showing its face. One of the great moments came when astronomers began mapping what became known as the Great Wall, a structure over 500 million light-years long. To think of anything that size is dizzying. To realize it exists and is made of galaxies is almost impossible. Yet it proved that the universe was not a loose scattering, but something grander, bound by hidden forces. This realization changed astronomy. If there was a pattern, there had to be a cause. Something was guiding galaxies into place. Gravity was the suspect, but not the ordinary kind from visible matter. Something more was needed, something stronger, silent, and ever-present. Thus began the hunt for dark matter, the unseen glue behind the web. Every new map only confirmed the mystery further. The universe, it seemed, was like a puzzle, slowly revealing its picture. At first, only specks, then lines, then whole walls and filaments, and the more we traced, the clearer the image became. Ahead in this video, we will step into how the first galaxy maps grew into full simulations, showing us the entire web itself. Mapping millions of galaxies to see the invisible. To see the cosmic web, scientists needed more than a few hundred galaxies. They needed millions. That meant scanning the night sky with powerful telescopes and recording every galaxy's position. It was like charting stars across an ocean, a slow, careful task, but one that promised hidden treasure. Each galaxy was a dot on the map, and together they would reveal the secret structure. One of the most ambitious projects was the Sloan Digital Sky Survey. Beginning in the 1990s, it aimed to map galaxies with detail never attempted before. Night after night, data poured in, millions of galaxies spread across billions of light years. The more data collected, the clearer the pattern became. Filaments, clusters, and voids stood out like veins in the body of the cosmos. What made it striking was how natural the shapes looked. The galaxies were not arranged in straight lines or perfect circles. Instead, they curved and branched like rivers flowing across a landscape. It was an organic design, as though the universe itself were alive, weaving its own skeleton beneath the stars. The randomness of old theories faded away, replaced by this breathtaking order. For many scientists, the moment the first full maps were revealed was unforgettable. They saw not just dots of light, but a living structure. The cosmic web was no longer theory, it was right there on the screen. And though invisible to the eye, it was as real as the galaxies themselves. Like bones under skin, it shaped everything we see above us. The maps continue today, sharper and larger with each survey. We now have a rough outline of the universe's web, and yet so much remains unknown. Ahead in this video, we'll explore how simulations allowed us not just to map the web, but to watch it form, like seeing the universe grow from infancy to the vast net we see today. The first computer, simulations of the cosmic web. Before computers, astronomers had only their telescopes and their theories. But once machines became powerful enough, something magical happened. They could recreate the universe itself. By entering the laws of physics and the initial conditions after the Big Bang, they pressed go and watched billions of years unfold in moments. What appeared on their screens was astonishing, the cosmic web, forming naturally, without human design. At first, the simulations were small, showing only tiny regions. But as computing power grew, they expanded. The Millennium simulation, for example, tracked billions of particles of dark matter across a virtual universe. The result was breathtaking. Filaments of galaxies, knots of clusters, and voids stretching vast and empty. It was as though the computer had painted the universe's hidden skeleton for the first time. What made these simulations so powerful was their accuracy. When compared with real observations, they matched almost perfectly. The same shapes, the same structures, the same delicate balance of clusters and voids. It confirmed what astronomers had begun to suspect. The cosmic web was not an accident. It was a natural result of gravity and dark matter shaping the universe since its birth. Imagine seeing billions of years of history compressed into a movie, watching tiny ripples grow into sprawling filaments, galaxies forming like drops of dew on a spider's web. That is what these simulations revealed. They allowed scientists to witness creation itself in a way no telescope ever could. They were not just science, but visions of the universe's secret story. And yet, as precise as they are, simulations still raise questions. What role does dark energy play? Will the web stretch forever, or will it change form? Ahead in this video, we'll move into the strange comparisons people have made, how the cosmic web mirrors things we know from everyday life, from soap bubbles to the brain itself. The shock. Galaxies shaped by gravity like droplets. The greatest surprise was realizing how much galaxies resemble droplets on a window. When rain gathers, it flows into paths, merging into streams, leaving empty spaces between. The cosmic web is the same. Galaxies flow along filaments of gravity, gathering where streams meet, leaving behind giant voids. It is nature repeating itself from raindrops to rivers to galaxies. Gravity is the unseen artist here. Just as water follows valleys on Earth, galaxies follow the valleys carved by dark matter. These valleys are not made of rock, but of gravitational pull. Matter slides into them, gathering into luminous rivers of light. Clusters form at the junctions just as lakes form where rivers meet. It is a simple rule, repeated on unimaginable scales. What makes it shocking is how familiar it feels. The universe is unimaginably large, yet it behaves in patterns we see every day. From water to lightning, from roots to neurons, the same designs appear. The cosmic web is not separate from nature. It is nature magnified to infinity. It shows us that the laws of growth, flow, and balance are universal. Astronomers often describe this moment of realization as almost spiritual. To look at the cosmic web is to feel that the universe itself breathes in patterns. It is not chaos, it is not noise, it is design, even if unintentional. The galaxies are droplets pulled together by gravity's hand, falling into the shape of the cosmos itself. To see it is to feel awe. This shock reshaped our understanding of the universe. Galaxies are not just islands of stars, but parts of a larger flow, a current of creation. Ahead in this video, we will step into an even stranger idea, that the universe looks like soap bubbles in reverse, with voids as the bubbles and galaxies as the thin walls between. Why the universe looks like soap bubbles in reverse. If you've ever blown soap bubbles and watched them cluster, you've seen a clue to the universe's design. The bubbles press together, leaving thin walls where they meet. The cosmic web is similar but inverted. Instead of bubbles filled with air, we have cosmic voids filled with emptiness. Instead of thin walls of soap, we have filaments of galaxies forming the outlines. It is as if the universe is a foam, frozen in time. This image helps us understand why voids exist. They are not mistakes or gaps. They are the natural spaces left when matter is pulled into filaments. Just as bubbles define their shapes by the walls between them, voids define the shape of the cosmic web. The emptiness is as important as the galaxies themselves. Without the voids, the structure would collapse, losing its balance. What fascinates astronomers is how regular the pattern is. The voids are vast, but they follow rules. They expand, merge, and reshape, leaving behind the delicate threads of galaxies. It is a dance of emptiness and matter, silence and light. Each void is hundreds of millions of light-years wide, and yet they fit together like a puzzle, forming the background of our universe. To compare the cosmos to bubbles may sound playful, but it is remarkably accurate. It brings the infinite down to something you can picture in your hands, and it reminds us that nature loves repetition. From bubbles to galaxies, the same principles unfold. The cosmic web is not only scientific, but deeply human, a pattern we can feel as much as we can measure. And so the universe, in its largest form, resembles a froth of bubbles reversed, emptiness inside, light on the edges. Ahead in this video, we'll explore what the web is truly made of, from dark matter to streams of gas, and how these threads feed galaxies like rivers feeding life on Earth. The role of dark matter as the invisible framework. Dark matter is perhaps the strangest part of the cosmic web. We cannot see it, touch it, or shine light on it. Yet it outweighs all visible stars and galaxies combined. Imagine trying to study a cathedral when you can only see the stained glass windows, but never the beams holding it up. That is what dark matter is. The invisible beams, the unseen bones of the universe's grand cathedral. Without dark matter, the web would collapse. Ordinary matter, the kind that makes stars, planets, and you and me, is simply not enough to hold galaxies together. Gravity from visible matter is too weak, but dark matter, spread like a ghostly sea, provides the hidden pull. It shapes valleys in space, and into these valleys gas and galaxies fall. The web is drawn not by light, but by this invisible hand. Astronomers discovered dark matter indirectly. They noticed galaxies spinning too fast to hold themselves together with visible stars alone. Something unseen was adding weight, keeping them bound. Over time, this mystery grew until it became clear. Dark matter was not just a small ingredient. It was the main framework of the cosmic web, the skeleton on which everything else was built. Simulations showed this vividly. When only ordinary matter was included, the universe stayed too smooth. But when dark matter was added, suddenly filaments and clusters appeared, matching the real maps. It was proof. The invisible framework was real, even if we could never see it directly. Dark matter was no longer a shadowy guess, but the keystone of the cosmic design. This makes you wonder how much of life is shaped by things unseen. Just as galaxies owe their places to dark matter, Our lives are often steered by forces we cannot measure: memory, chance, connection. The cosmic web reminds us not all truths are visible. Ahead in this video, we'll drift into the quieter side of the web, the rivers of hydrogen gas flowing along its filaments. Hydrogen gas streams as cosmic veins. Dark matter may be the skeleton, but hydrogen is the lifeblood of the cosmic web. Long before galaxies formed, hydrogen filled the universe, spreading like mist. Over time, gravity gathered it into rivers flowing along the filaments. These invisible streams continue to this day, feeding galaxies, fueling the birth of stars. It is as if the web itself breathes, inhaling and exhaling gas through its endless veins. Astronomers discovered these hydrogen rivers not by direct sight, but through their faint glow in radio waves. By tuning their instruments, they traced the delicate filaments of gas threading between galaxies. What they saw confirmed the web's structure, not just dark matter, but gas flowing into galaxies like rivers feeding trees. Each drop of hydrogen, each current, eventually became part of a star shining across space. This process is called cosmic accretion. It is quiet, steady, and vital. Galaxies grow fat on these streams, creating new stars over billions of years. Without them, galaxies would wither. The Milky Way itself drinks from these cosmic rivers, ensuring the stars keep burning, the planets keep forming, and life itself has a chance to exist. It is humbling to realize we live on light, born from rivers that stretch across eternity. Sometimes, when you watch rain soaking into soil, you are watching the same principle. Water flows along paths, invisible until the ground is wet. In the universe, hydrogen flows along paths carved by gravity, invisible until galaxies shine. The echo between the small and the infinite is everywhere. The cosmic web is nature repeating itself on every scale imaginable. And so the cosmic web is not only a skeleton, but a circulatory system. Dark matter holds the frame. Hydrogen gas streams carry the lifeblood. Together, they sustain galaxies across time. Ahead in this video, we'll turn to the filaments themselves, immense bridges of galaxies stretching across hundreds of millions of light years. Filaments stretching for hundreds of millions of light years. Picture a bridge so vast that it takes light, the fastest thing in existence, hundreds of millions of years to cross. That is what the filaments of the cosmic web are. These are not small structures. They are highways of galaxies threading the universe, guiding matter into clusters and superclusters. To imagine one is to imagine the unimaginable, and yet they are real, mapped by science and confirmed by the stars themselves. Each filament contains not just galaxies, but dark matter, gas, and invisible energy. They are tubes of creation, funnels through which the universe pours its matter. At their intersections lie the brightest clusters, like cities where highways meet. Along their length, galaxies are arranged like streetlights, glowing faintly, marking the invisible road they travel. It is breathtaking to realize we live inside one such road, part of this infinite network. These filaments also explain why galaxies move the way they do. They do not wander randomly, they flow along the strands carried by gravity's tide. The cosmic web acts like a current in an ocean, and galaxies are its drifting ships. Without the web, their motion would be chaos. With it, their paths are ordered, graceful, part of a cosmic dance that never ends. Astronomers call this the large-scale structure of the universe, but the phrase feels too small. It is not just large, it is beyond scale. Filaments are not visible to our eyes, but when drawn on maps they resemble strokes of light across a canvas. The universe, it seems, is an artist painting in silence, using gravity as its brush and galaxies as its ink. And what is even more stunning, these filaments are not rare. They span everywhere, connecting all clusters, shaping all voids. Ahead in this video, we'll arrive at those knots of brilliance. The galaxy clusters that form where filaments intersect, glowing like lanterns in the night. Galaxy clusters as the bright knots of the web. At the crossroads of the cosmic web, where filaments meet, lie the galaxy clusters. These are the brightest knots in the tapestry, home to hundreds, sometimes thousands, of galaxies bound tightly together. If filaments are the roads, clusters are the cities, bustling, crowded, and full of energy. They are the places where the web's threads tie strongest, holding galaxies in a gravitational embrace. Clusters are not just collections of stars, they are powerhouses of gravity. Within them lies not only galaxies, but massive halos of dark matter and pools of hot gas. This gas glows in X-rays, invisible to our eyes, but blazing in the instruments of telescopes. Through these glowing signals, astronomers can trace the knots confirming the web's design. Every cluster is a lighthouse marking the crossroad of filaments. The largest of these are called superclusters, chains of clusters linked together. Our own Milky Way belongs to the Laniakea supercluster, a vast region where threads converge. To know we live inside such a knot is to realize our galaxy is not isolated, but part of a greater family bound by the web's gravity. We are not drifting, we are anchored to a thread larger than our imagination. Clusters also reveal how violent the web can be. Galaxies within them collide, merge, and reshape each other. These interactions trigger bursts of star formation, or sometimes strip galaxies bare, leaving them lifeless. Clusters are both the cradles and the graveyards of galaxies. They are proof that the web is not still but alive, evolving with every billion years that pass. And so galaxy clusters are more than bright knots. They are the punctuation marks in the universe's story, the glowing intersections where the hidden threads become most visible. Ahead in this video, we'll step into the opposite side of the design. The voids, those immense empty spaces that give the web its striking contrast. Voids, the great empty bubbles. Between the threads, perhaps the most haunting part of the cosmic web is not the filaments nor the clusters, but the voids. These are the empty bubbles of space, vast beyond comprehension, where almost no galaxies exist. Some span hundreds of millions of light years, silent deserts in the middle of the universe. If the web is lace, the voids are the holes in between, just as essential, just as beautiful in their emptiness. It may seem strange to value nothingness, but in the cosmic web, voids define everything. They push matter to the edges, shaping the filaments and clusters. Without voids, the web would not exist. They are the negative space, the pauses in the music, the silence that makes the sound meaningful. The contrast between full and empty is what gives the universe its shape. Astronomers study voids to understand dark energy. These vast regions expand faster than their surroundings, as though emptiness itself is being stretched. By measuring them, we learn about the force that drives the universe's expansion. The voids, though quiet, are not useless. They are laboratories for the strangest physics, teaching us about the very fate of the cosmos itself. And yet voids are not completely empty. A few lonely galaxies wander inside them, far from their neighbors. These are the hermits of the universe, cut off from the filaments, surviving in silence. They remind us that isolation is possible, but rare. Most galaxies choose the threads, only a few endure in the void's haunting stillness. Their stories are among the most mysterious in astronomy. So when we picture the cosmic web, we must honor the voids as much as the filaments. Without the dark spaces, there is no design, no balance, The universe is shaped as much by absence as by presence. And ahead in this video, we'll travel into how galaxies themselves live inside the web and how these threads decide where stars are born and where silence remains. How galaxies form where filaments intersect. If you could drift along the threads of the cosmic web, you would notice something fascinating. At the points where filaments cross each other, galaxies bloom in abundance. These intersections are like fertile crossroads, where the streams of hydrogen and the pull of gravity gather enough matter to ignite the birth of new galaxies. It is no accident that clusters form here. It is written into the very design of the web. Galaxies need raw material, gas, dust, and dark matter halos to grow. Along the filaments, these materials flow like rivers. At intersections, the flow slows down like water pooling into lakes. Here, galaxies gather, collide, and merge, feeding on the endless supply of hydrogen that pours in from every side. It is a place of activity, of creation, of cosmic abundance. The web decides the locations, gravity does the rest. Scientists discovered this by comparing simulations with real observations. Over and over the same story unfolded. Galaxies do not form randomly, but in places where filaments overlap. It is as though the web itself is a gardener, planting seeds at intersections, letting galaxies sprout where the soil is richest. Even our own Milky Way may owe its place to such a crossroads long ago. What's striking is how universal this principle is. On Earth, cities often grow where rivers meet, where trade and travel are richest. In space, galaxies follow the same law, flourishing where streams of matter converge. The universe repeats itself, from the smallest village to the largest cluster. Patterns, it seems, are written into existence itself. So the next time you look at the Milky Way, think of it not as chance, but as part of a larger plan. A galaxy born where threads of gravity crossed, where rivers of gas flowed. Ahead in this video, we'll follow those streams more closely, seeing how they feed galaxies like veins, carrying nourishment to a living body. Streams of gas, feeding new stars like rivers. Galaxies are hungry creatures. To make new stars, they need a constant flow of gas, mostly hydrogen. Without it, they become barren, unable to form fresh light. The cosmic web provides this fuel through streams of gas flowing along its filaments. These rivers are invisible to the eye, but they are the lifelines of galaxies, feeding them for billions of years. Astronomers call this cold gas accretion. The gas does not burn hot, but stays cool enough to slip into galaxies, settling into their disks, where gravity squeezes it into stars. In this way, galaxies are not closed systems. They are open mouths, constantly drinking from the cosmic rivers that surround them. Without these rivers, galaxies would fade away. With them, they shine across time. This explains why galaxies near filaments thrive, while those in isolation slowly starve. The streams of the web deliver nourishment directly to their cores. Imagine a tree planted near a river. It grows tall, lush, and vibrant. But a tree planted in dry ground struggles. Galaxies follow the same rule, living or dying depending on their connection to the streams of the web. These rivers also create balance, too much gas, and galaxies burst with star formation, sometimes shining so bright they burn out quickly. Too little, and they fade into silence. The cosmic web regulates this flow, giving just enough to keep galaxies alive for billions of years. It is a delicate balance, tuned by the hand of gravity itself. So when you look at the stars above, remember that each one was born from a drop of hydrogen carried along a cosmic river. Ahead in this video, we'll see why galaxies are rarely alone and how they gather into families, held together by the same threads of the web. Why isolated galaxies? Rare in the universe. At first thought, you might imagine galaxies drifting in perfect solitude, far away from neighbors, but true isolation is rare in the cosmos. The web ensures that galaxies are bound together, often in pairs, groups, or larger clusters. Like leaves on a branch, they belong to something greater, connected by the invisible lines of gravity. Solitude, in the cosmic sense, is almost an illusion. Astronomers do sometimes find field galaxies, those living on the edges of filaments, away from dense clusters. Yet even these are not fully alone. They still trace the shape of the web, still flow along its gravity. Their isolation is relative, never absolute. The pull of the cosmic net ensures that no galaxy is ever truly disconnected. This interconnectedness is a safeguard. Galaxies interact, share gas, and sometimes collide, sparking bursts of new stars. These encounters may seem violent, but they keep galaxies alive, reshaping them, giving them new light. Without such connections, galaxies would wither faster, deprived of material and companions. Even loneliness in the universe is temporary, as gravity eventually draws neighbors together. In fact, some of the most beautiful sights in astronomy come from galaxy pairs or groups. Spirals twisting into each other, stars flung across space like sparks from a fire. These dances are only possible because galaxies are tied to the same web. Their encounters are not random accidents, but outcomes of belonging to a larger structure. So, while solitude may seem natural on Earth, in the universe it is rare. The cosmic web ensures that galaxies live in company, in conversation, forever bound by gravity. Ahead in this video, we'll move to the grander stage, clusters of galaxies that travel together along the threads like caravans on ancient roads. The dance of clusters. Along the threads, clusters are not fixed points in space. They move, pulled by the threads of the cosmic web. Imagine great caravans of galaxies sliding along invisible roads, heading toward crossroads where they will meet other clusters. This is the dance of the cosmos, slow, majestic, and guided by gravity. It is a ballet that has been unfolding for billions of years, with no audience but the stars. Astronomers call this flow large-scale motion. Galaxies and clusters drift along filaments drawn toward the densest regions. These movements are so vast, so slow, that we cannot see them in a human lifetime. Yet over billions of years they change the shape of the universe. Clusters merge, grow larger, and reshape the web itself. The dance never ends, it only evolves. What's remarkable is how predictable it is. Gravity follows simple rules, and yet, from these rules emerges complexity and beauty. Just as rivers find the sea, clusters find one another, gathering into superclusters, then into even larger structures. The cosmic web is not static, but flowing, shifting like tides across eternity. We live in the midst of this motion, carried unknowingly along one of its streams. Our own Milky Way, with its neighbors, is drifting towards something called the Great Attractor, a region of immense gravity pulling entire clusters together. Though invisible, its tug is real, and it shows us that we too are part of the dance. Galaxies may seem still in the sky, but in truth they are flowing like dancers across a cosmic stage. And so the dance of clusters is both scientific and poetic. It is the reminder that nothing in the universe is still, that all things are in motion, drawn along threads of connection. Ahead in this video, we'll see how the web does more than guide galaxies. It organizes entire superclusters, the largest gatherings of matter in the known universe. How the web guides the motion of entire superclusters. On the largest scales, the cosmic web is not just about galaxies or clusters, but entire superclusters, regions containing hundreds of thousands of galaxies. These giants are not randomly scattered. They too flow along the web, guided by the pull of dark matter and gravity. The web is the silent map, and superclusters are its travelers, moving slowly through cosmic time. Take Laniakea, our home supercluster. It is vast, spanning 500 million light-years, and it exists because the web guides galaxies and clusters into its embrace. Without the web, such immense structures would never form. It is like watching entire continents drift on tectonic plates, but here the plates are made of gravity and dark matter, shifting the very architecture of the universe. What fascinates astronomers is how these flows are connected. Superclusters are not isolated islands, they are part of the greater weave. The motion of one influences another like tides in an ocean. The web ensures balance, spreading matter evenly but not randomly. It is a cosmic choreography, a design so large it defies comprehension, yet so precise it leaves no doubt of its order. Simulations confirm this. When scientists let gravity work on dark matter across billions of years, superclusters naturally form along filaments. They are not added later, but grow as part of the web itself. Their motions reveal the hidden hand of the structure, pulling them together into patterns far greater than any human design. Even at this unimaginable scale, the web is in control. And so the cosmic web is not just a backdrop. It is the guide, the architect, the silent force shaping the paths of entire superclusters. It reminds us that even the greatest giants in the universe must follow the same laws, the same threads, as the smallest galaxy. Ahead in this video, we'll rise to an even grander perspective. The scale of the cosmic web itself, larger than imagination, and stranger than anything we thought the universe could hold. A structure larger than imagination. The scale of the cosmic web is almost impossible for the human mind to hold. We measure distances in kilometers, perhaps in millions, yet here we must think in light years. And not just a few, but hundreds of millions, even billions. A single filament can stretch longer than any cluster of galaxies, longer than anything we can truly picture. It is the largest structure ever discovered, and it is still only a fraction of the whole. Astronomers often say that when you try to imagine it, you must let go of ordinary numbers. A filament can be hundreds of millions of light-years long. A cluster can span tens of millions. A void can be so wide that light, traveling since the time of the dinosaurs, would still not reach across it. These are not just numbers, they are reminders that our universe is vaster than imagination itself. The scale forces us to see our place differently. On Earth, we think of mountains as immense, oceans as infinite. But against the cosmic web, they are whispers, specks of dust. Even our galaxy, the Milky Way, is a single thread of light in a vast, stretching highway. The scale is humbling, but it is also comforting. We are small, but part of something unimaginably grand. This scale also reveals order. Despite its vastness, the web is not chaotic. Its filaments connect, its clusters gather, its voids balance the rest. Even across billions of light years, the same shapes repeat, the same patterns echo. It is as if the universe loves symmetry, loves balance, no matter how big it becomes. The larger we look, the more we find harmony hidden in the scale. And yet, even at this immense size, the web may not be the limit. There could be structures even larger waiting to be discovered. Ahead in this video, we'll step into one of the most fascinating comparisons scientists have made, how the cosmic web resembles something far more familiar, the human brain. Comparing the web to a giant brain, when scientists looked at detailed maps of the cosmic web, something startled them. The pattern of galaxies and filaments looked strikingly similar to the neurons in a human brain. Two systems separated by scale beyond comprehension, yet echoing each other's design. The universe itself seemed to reflect the architecture of thought, as though mind and cosmos were mirror images of one another. Neurons in the brain connect through synapses, forming networks that carry information. Galaxies connect through filaments, forming pathways that carry matter and energy. Both systems are built from nodes and connections, both thrive on balance between emptiness and fullness, and both create emergent complexity from simple rules. The likeness is uncanny, so much so that some scientists began comparing their statistical properties, and they matched. Of course, this does not mean the universe is thinking, at least not in the way we do, but the similarity raises deep questions. Why do such different systems, one biological, one cosmic, arrive at the same structure? Perhaps it is the nature of networks themselves, a universal law of connection that repeats across scales, from neurons to galaxies. This comparison also touches the human imagination. To look at the night sky and see something that mirrors your own brain is a humbling thought. It suggests we are not separate from the cosmos, but expressions of the same patterns. The architecture of thought and the architecture of galaxies are cut from the same invisible cloth. The universe contains us, but in a way it also reflects us. And so the web and the brain are both networks of light, one inside the skull, the other across the stars. Ahead in this video, we'll see how these repeating patterns continue, not just in brains, but in fractals, roots, rivers, and lightning, reminding us that the universe is filled with echoes of itself, patterns that repeat like fractals. The cosmic web reveals a truth that nature whispers everywhere. Patterns repeat. On the smallest scales, we see branching veins in leaves, roots of trees, rivers across landscapes. On the grandest scale, we see galaxies aligned in filaments. The design is fractal-like, repeating shapes across different sizes from the microscopic to the infinite. The cosmos seems to favor certain patterns, weaving them again and again. A fractal is a pattern that repeats no matter how closely you look. The cosmic web behaves in a similar way. Zoom in and you see galaxies arranged in filaments. Zoom out and you see clusters arranged along larger filaments. The shapes do not vanish, they continue, echoed endlessly across scales. It is as though the universe is built from one design, stamped in different sizes. This fractal nature comforts us because it ties the grand to the familiar. When you watch lightning crack across the sky, you are seeing a design not so different from galaxies spreading across space. When you hold a fern leaf, you are holding a mirror of cosmic filaments. Nature repeats itself because it works, because it balances beauty and efficiency. The web is the largest echo of this truth. Astronomers marvel at how these patterns emerge from simple laws. Gravity, flowing gas, the expansion of space. From these basics comes endless complexity, endless fractals. It is proof that simplicity and depth are not opposites. The same law that bends a river can shape a galaxy cluster. The same branching that guides a root can carve a filament of galaxies. And so, the cosmic web is not alone in its design. It belongs to a greater family of fractals, repeating across creation. Ahead in this video, we'll look at another comparison. Why the web resembles frozen lightning, branching across the cosmos like electricity caught in eternal stillness. Why the web looks like lightning, frozen in space. Imagine lightning frozen at the moment of its strike, its branching tendrils stretching outward. That is how the cosmic web appears. The filaments twist and fork, reaching across the voids like bolts of electricity. It is as if a single flash of lightning was stretched into billions of light years and left to hang in silence forever. The resemblance is not just visual. Both lightning and the web form through pathways of least resistance. Electricity flows through air where it can move most easily. Galaxies flow through space along gravitational valleys carved by dark matter. Both create branching networks, delicate yet powerful, shaping the world around them with invisible forces. Lightning is quick, lasting only a fraction of a second. The cosmic web, in contrast, is slow beyond time, forming over billions of years. Yet the principle is the same, forces flowing through a medium, leaving behind branching patterns. One strikes across the sky, the other stretches across the universe. Both remind us that beauty does not depend on scale, only on design. When scientists first simulated the cosmic web, they too noticed this lightning-like quality. The filaments did not line up neatly, they forked, split and branched, just as electricity does. It was another sign that the universe's design was not chaos, but a repeating principle of nature. Patterns emerge wherever forces flow, whether in storms or in galaxies. So when you next see a lightning flash in the night, remember you are seeing a tiny echo of the universe's own web. One lasts a moment, the other eternity. Ahead in this video, we'll face an even more mysterious question. Does the cosmic web have an end, or does it stretch forever into infinity? The question, does the web ever end? This is perhaps the most haunting question of all. Does the cosmic web have a boundary, or does it go on forever, stretching beyond our vision, beyond even the reach of light? Astronomers do not yet know. We can map billions of light years, but the universe may be endless. The web may simply continue, thread after thread without end, a net that has no edges. Our visible universe is limited by the speed of light and the age of the cosmos. Beyond what we see, the web likely continues, unseen, untouched. It could be infinite, or it could fold into something stranger. Some theories even suggest other webs, other universes connected by unseen bridges. We are left with mystery, standing at the edge of a map that refuses to end. The human mind struggles with infinity. We are used to beginnings and endings, to borders and edges, but the cosmic web defies this. It may have no final wall, no outer shell, just endless filaments, endless voids, endless galaxies. The more we try to grasp it, the more it slips beyond reach. Infinity is not something to solve. It is something to sit with, quietly. And perhaps that is the point. The web is not meant to be contained in thought. It is meant to inspire wonder. Just as a child cannot hold the ocean in their hands, we cannot hold the cosmic web in ours. It asks us not to master it, but to accept our place within it. We are not outside it, but threads inside the net. So, does the web end? Perhaps yes, perhaps no. The mystery itself is part of the beauty. Ahead in this video, we'll step into the heart of what makes this possible, the power of gravity, the silent architect weaving these threads across eternity. How gravity sculpted the threads after the Big Bang. In the beginning, the universe was a smooth sea of energy, almost uniform, almost silent. But there were tiny ripples, slight differences in density, like whispers in the fabric of space. Gravity found those whispers, and over billions of years pulled on them. Where matter was a little denser, it became denser still. Those ripples grew into filaments, clusters, and voids. The cosmic web was born from the simplest of differences. Gravity worked slowly, but relentlessly. It is not a sudden force. It is patience itself, tugging gently, never letting go. Like a sculptor chiseling away at stone, gravity carved the universe. It drew galaxies into lines, stretched clusters along filaments, and hollowed out vast voids. What we see now, the grand design of the cosmic web, is the result of gravity's patient hand, shaping for nearly 14 billion years. We sometimes imagine the Big Bang as chaos, but gravity turned chaos into order. Without it, matter would have stayed scattered, too thin to form stars or galaxies. Gravity took the randomness and spun it into patterns, pulling matter into valleys, leaving emptiness behind. Every star that shines, every planet that orbits, owes its existence to that ancient sculpting force. Scientists can trace this process with simulations. They start with a universe of ripples, add gravity, and watch. What emerges is uncanny: filaments, clusters, voids, all forming exactly as observed. The conclusion is clear: gravity was the architect, and the web is its masterpiece. Without gravity, there is no cosmic skeleton, no design, no light at all. And so when you think of gravity, think beyond apples falling from trees. Think of a force so patient it shapes eternity, a hand so silent it carves galaxies. Ahead in this video, we'll look more closely at how this pull worked across time. The slow gravity tides that shaped the web into what we see today. The slow pull over billions of years. Time is the secret ingredient in the making of the cosmic web. Gravity does not rush. It works over billions of years, turning tiny seeds into massive filaments. Imagine watching a river erode a mountain. Slow, steady, yet unstoppable. That is gravity across cosmic time. It begins with ripples and ends with a structure spanning the universe. For the first 100 million years after the Big Bang, the universe was mostly dark, filled only with hydrogen gas, but gravity kept pulling on the ripples. Slowly, the gas gathered into knots, igniting the first stars. These stars formed galaxies, and the galaxies gathered into filaments. Each step took millions of years, yet the direction was always the same, toward order, toward the web. This slow pull continues even today. Galaxies still drift, clusters still merge, voids still expand. Though we cannot see it in our lifetimes, the universe is moving, shifting, reshaping itself under gravity's pull. If we could speed up time, the cosmos would look alive, filaments flowing like veins, galaxies sliding like drops along a web. What seems still is always in motion. It is humbling to think of this timescale. Human history, even the rise of civilization, is a blink compared to the life of the web. While we measure time in years and generations, gravity measures it in eons. Its patience dwarfs our own, its persistence beyond imagination, and yet through its slowness it builds beauty too large for us to ignore. So the web is not only a story of space, but of time itself. Ahead in this video, we'll discover how gravity acts as a universal storyteller, shaping galaxies into chapters, clusters into paragraphs, and the cosmic web into the grand book of the universe. Gravity as the universal storyteller. Every culture has told stories about the stars, but gravity has been writing the universe's story since the beginning. It is the silent narrator arranging galaxies into patterns, deciding where stars are born and where silence remains. Without it, the universe would have no chapters, no structure, no story at all. Gravity is the ink, the paper, and the hand that writes creation. Think of a galaxy as a character. Alone, it has its own history, its own stars. But placed within the web, its story changes. It interacts, collides, merges, and evolves. Clusters become plots. Filaments become threads of narrative, binding everything together. The web is not just a structure. It is a storybook of galaxies, authored by gravity itself. Astronomers sometimes call this cosmic evolution. Galaxies are not static, but living chapters that grow and change. A spiral may merge into an elliptical. A quiet galaxy may burst with new stars after an encounter. All of this is guided by the web, by the invisible storyteller who never rests. We are not just readers of this story, we are part of it, written into its pages. The idea of gravity as a storyteller brings comfort. It means nothing is truly random. Just as a plot unfolds slowly, so does the universe. We may not see the whole arc, but the direction is there. The web assures us that creation is not scattered chaos, but a flowing narrative stretching across eternity. So when you gaze at the night sky, imagine the book unfolding, each star a word, each galaxy a sentence, each filament a thread of story. Ahead in this video, we'll step into gravity's method, how it weaves like an invisible weaver, stitching galaxies into place across the fabric of space. Why gravity works like an invisible weaver. A weaver sits at a loom, pulling threads into patterns. Gravity does the same with galaxies. It gathers matter, stretches it into lines, ties knots at intersections, and leaves open spaces where no thread lies. The cosmic web is gravity's tapestry, woven silently, endlessly, across the fabric of space. We are all strands in that design, threads we cannot see but belong to. The weaving is delicate, yet strong. Filaments are thin, often only a few million light-years across, but they stretch across unimaginable distances. Like silk threads, they seem fragile, yet they hold clusters of galaxies in place. Gravity ensures the weave does not break, balancing tension and pull, keeping the fabric of the cosmos intact. The patterns also reveal something profound: balance. Too tight a weave, and galaxies would collapse into chaos. Too loose, and they would drift apart, lost in voids. Gravity weaves with perfect tension, enough to hold, enough to allow movement. This balance is what keeps the universe alive, its tapestry, both strong and flexible, never static, but never unraveling. Astronomers see this weaving in motion. Clusters drift together, filaments stretch tighter, voids expand. The pattern evolves, but the weaving remains. It is as if gravity is not only an architect, but also a craftsman, creating something both useful and beautiful. The cosmic web is more than physics, it is artistry on a scale beyond imagination. And so when we call it the web, we are not only describing its shape, we are describing its craft. Gravity is the weaver, galaxies the threads, space the loom. Ahead in this video, we'll follow the last step of this weaving, how galaxies ride along gravity's tides, flowing like boats on a cosmic ocean. Galaxies riding along the tides of gravity. Galaxies may seem fixed in the sky, but they are not. They drift, pulled gently by the tides of gravity. Like boats carried by currents, they slide along filaments, flow into clusters, and sometimes collide at crossroads. The web is not just a static design, it is a moving ocean, and galaxies are forever passengers on its waves. These motions are slow, taking billions of years, but they are powerful. Whole clusters shift, drawn toward each other. Superclusters merge, reshaping the web. The universe, though vast and still to our eyes, is in truth dynamic, forever flowing. We are like ants on a drifting log, unaware of the river that carries us. This motion explains why galaxies often end up in groups or collisions. They are not wandering aimlessly, but following the currents of dark matter's gravity. The tides guide them, push them, and sometimes crash them together. From these motions come new stars, new shapes, even new galaxies. Motion, though slow, is the breath of the web. Astronomers track these motions by watching how galaxies' light shifts, the telltale sign of movement. And what they find is remarkable. Every galaxy is riding along, including our own Milky Way. We too are drifting toward the great attractor, carried by the tide, unable to resist gravity's current. Even our home is part of the flow. So galaxies are not fixed lights, but travelers. They ride the tides of gravity, forever passengers in the great ocean of the web. And ahead in this video, we'll step away from the mechanics and see how human, with telescopes and maps, first began to trace these invisible patterns across the night sky.